imagine if you were to insert the probe inside of the fox cerebri, you would be in
Superior sagittal sinus.
superior sagittal sinus, yes. And the other piece of the dural reflection that is actually right here separates the two cerebral hemispheres from the cerebellum, which would sit right in here. So these are the tentorium cerebelli. These would, again, separate cerebrum from cerebellum. So that's the dura. And then you want to delineate sulci and fissures. So we have the longitudinal fissure, which is this large one that separates the right and the left cerebral hemispheres. So this is the longitudinal fissure. And this is where the fox cerebri would actually fit in between. And then we want to delineate the central sulcus. And for that, we're going to follow the longitudinal fissure, starting from an anterior aspect, working our way back until we meet the largest sulcus, and it would be right in here. Here's our largest sulcus. This is the central sulcus. Anterior to that, we have the frontal lobe. Posterior to that, we have the parietal lobe. And then if we look at the brain laterally, we can delineate the lateral sulcus. And that's this one right here. The lateral sulcus separates the inferior lobe, the temporal lobe inferiorly from the frontal lobe, anterior superior, and the parietal lobe superior. So the lateral fissure separates the temporal lobe from the frontal and parietal. And on the ventral aspect of the brain, here's the temporal lobe. The most inferior and medial aspect of the temporal lobe is the parahippocampal gyrus. There it is on the other side. And then lateral to it, we have the rhinal fissure. So that's the rhinal fissure. Okay, and then on the mid-sagittal section, here we'll find the parieto-occipital sulci and the calfrine sulcus. So that's on the mid-sagittal and in the human only. Here's the parieto-occipital sulcus. Separates the parietal lobe anteriorly from the occipital lobe posteriorly. And then we have the calfrine sulcus running through the occipital lobe, and that's where we have our primary visual cortex. Calfrine sulcus. So this is calfrine sulcus, this is parieto-occipital sulcus. Let's do the mid-sagittal first, since I have it in here. Nerves and muscles. Right here is the cingulate gyrus. And the depression that's just superior to it is the cingulate sulcus. And just inferior to that, we have corpus callosum. 3 locations: genu, body, splenium. Septum pellucidum is this thin membrane that separates the right and the left lateral ventricles. And so we have a lateral ventricle where I inserted my probe. The fornix is missing on the specimen, but it would run right in here. Yeah, I don't have it on the other one. So fornix would come in this direction, move forward, and then right in here, you'll have a round little structure. It's usually whitish in your specimen, and that would be the anterior commissure. So this is the anterior commissure. Just inferior to the fornix, we're going to have this space right here. This is the third ventricle. So from the lateral ventricles, right here, we have a little canal that actually connects to the third ventricle. The walls of the third ventricle are the thalamus. So this tissue right here that I'm pointing at is actually thalamus. So on the test, if I point at the tissue and I say, what is this tissue? The answer is going to be thalamus. If I point at the tissue and I say, what's this space? Then I want the third ventricle as the answer. And that's how you can tell the two apart. The third ventricle is the space. Also, right on the midline right here, we have this little tissue that's massa intermedia of the thalamus. So this right on the midline is what connects the right and the left thalami, and that's massa intermedia of the thalamus. Posteriorly, if we go, we have the pineal body, and then inferiorly, we have the hypothalamus. Hypothalamus, we can delineate it by three structures. The anterior commissure, superior and anterior. Optic chiasm, inferior and anterior. And then posterior and inferior mammillary body. Hypothalamus. And then if we go posterior, we're going to have the midbrain. Posterior to the midbrain, we have the two little the colliculi. The larger one is the superior colliculus, and the smaller one is the inferior colliculus. And inferior to the midbrain, we have the pons. The third ventricle connects to the fourth ventricle via this small canal that opens up on here. It's closed over here, but it opens back up in here. And that's the fourth ventricle right here. And that canal is called the cerebral aqueduct of Gray. So right in here, through this tissue, we would have the cerebral aqueduct of Gray, and this would be your fourth ventricle. The cerebellum, then, we can divide it. What we see right on the midline, all of this tissue is the vermis. So on the test, if I point at this location, you can be specific and tell me that that's the anterior lobe of the vermis of the cerebellum, because I'm pointing in this area. Versus this one is the posterior lobe of the vermis of the cerebellum. This right here is the primary fissure. If I circle the entire structure, then I want the vermis of the cerebellum. So this is the vermis of the cerebellum, this is the vermis of the cerebellum, anywhere here except 5 point here, that's anterior lobe, and this is posterior lobe. Then on either side of the vermis, we have the cerebellar hemispheres. We don't really see it here, it's been chopped off, and so on. So any questions on the mid-sagittal? Here is the lateral ventricle on the left side. Now let's do blood vessels and cranial nerves. You want to start again labeling these or naming them anterior and work your way posterior. This is the olfactory bulb right here. I'm going to do cranial nerve first. So this is the olfactory bulb, that's cranial nerve 1. Optic nerve, cranial nerve 2. And we have the chiasm, and the one that goes back is the tract. So this right here is the optic tract. 3 is oculomotor right here. Trochlear is going to come out of the brainstem posteriorly, so this is trochlear right here. So this is the midbrain. And then we have pons and medulla. We said 4, it comes out of the brainstem dorsally. And then if we look at the pons, the first cranial nerve that we will encounter is going to be trigeminal. That's going to come out from the pons, superior and lateral to 6, 7, and 8. So all cranial nerves 5, 6, 7, and 8 are found in the pons. 5 is the superior and lateral one. 6, 7, and 8 come out of the junction between pons and medulla. 6 is going to be located most medial. This is 6 right here. And then if you go lateral, you will find 7 and 8. This is 7 right here. 7 is a small nerve, and it's just medial to 8. So this is 7. This is 7, and then that large one next to it is 8. 8's got 2 branches, so it looks a little bigger. And it's lateral to 7. Then if we come to the medulla, we're going to label 9, 10, 11, and 12. 9 and 10 come out of the medulla laterally. 9 is superior than 10 and smaller. 9 is smaller than 10. So 10 is larger and inferior to cranial nerve 9. And then if we go around the same level to the medial aspect, we will find 12. 12 comes out of the little bump, which is the olive. And then if we go lateral again, we will find these mini branches, which are 11. And that's the one accessory goes down all the way to the spinal cord. So these are the branches of the lung. For the blood vessels, we're going to start with the anterior cerebral arteries. So right here we have the anterior cerebral arteries going forward in this way, connected by the anterior communicating just underneath the optic chiasm. This is the internal carotid right here. The blood vessel coming back is laterally is the middle cerebral artery. And then we have the 2 smaller blood vessels forming a V here. This is the posterior communicating, and these are the posterior communicating arteries. Posterior communicating arteries are going to join and form the basilar right along the brainstem. Before they actually join the basilar, the posterior cerebral is going to branch off of them. So you remove the ocular nerve. This blood vessel right here is the posterior cerebral artery. So again, this comes off of the posterior communicating artery. And then after these posterior communicating arteries join and form the basilar, we're going to have the first blood vessel that comes out is the superior cerebellar artery. And then as we actually descend down the brainstem, we're going to have 2 blood vessels. We'll take the first one to be the anterior inferior cerebellar artery. And then the one that's inferior to it, this is going to be the posterior inferior cerebellar artery. So 2 blood vessels, one that's going to be just superior to the other. The first one is anterior inferior cerebellar. The second one is posterior inferior cerebellar artery. Then the basilar becomes the spinal artery in the sheath. And then, is it accessory spinal? Anterior, sorry. So it'll become the anterior spinal in the sheath. And then in the human, the basilar is going to give rise to the 2 vertebrals. So for this one, you'll have 2 blood vessels forming the vertebrals. Okay? Any questions on any of this?